Hi, everyone. My name's Courtney Brown, and I'm the marketing manager here at Enterprise DB. I'll be your host today for our webinar, Conquering Data Migration from Oracle to Postgres. I'm joined by Mark Linster, SVP of Product Development, as well as Raghav Rao, a managing consultant in the Professional Services Division at EDB. Before we get started, I wanted to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it into the question panel. If time allows, we'll go through the questions, and if not, we'll follow up afterwards with any attendee whose question was not answered. And now I'll turn it over to Mark.
All right. Thank you very much, Courtney. Okay, so without further ado, we're going to get going on the webinar, and we'll have time at the end for questions. And don't be shy. Raghavendra, this webinar is one of our most experienced migration consultants and understands Oracle and Postgres Advanced Server very well. So I'm sure we can hopefully get to everything. If we don't get to your question, we'll answer it in writing afterwards. Okay, so this is part of a series of webinars, and this is the second one. 2 weeks ago, Raghav and I did one on more of the schema migration focus. So, how do you get the schema, the DDL, the tables, the stored procedures, etc., over to from Oracle to Postgres. And today we're going to focus a lot more on the data migration, right, which was the second part of the equation. And then in 2 weeks, we're going to have a similar webinar about using Terraform and Ansible to deploy highly available Postgres. Also, if you have other subjects that you'd like us to talk about, just put them into the chat, and we'll add them to our list. Okay, agenda-wise, I'll talk briefly about who is EDB. It'll be very brief, promise, less than 5 minutes. Then we'll talk about methods for data migration, how snapshot migration works, how parallel snapshots work, and how change data capture works. And then we'll talk about the tools that are available to help you do that. Now, before we get going, anybody asks a question today and puts their shipping address into the question box will get a pair of EDB socks. And even though spring is coming, they're still coming handy. And Courtney tells me where we have the first people who are asking questions or actually just asking for their socks. So let us know, and we'll send you a pair of socks. Okay, so who's EDB? We've been available or working on Postgres, involved in Postgres since 2004. Since 2006, we've been regular contributors to PostgreSQL, and today we have over 4,000 customers with 300 employees worldwide, offices around the planet, and we've been recognized for our work in Postgres, and also Postgres itself has been recognized by Gartner and Forrester, and I'll get to that in a little bit. We are one of the major PostgreSQL community contributors today. So I mentioned Gartner, I mentioned Forrester. Let me just explore the Gartner aspect a little bit, because it's important when you think about migration to Oracle. Because what Gartner does is says, hey, is a company, a database company here, able to execute? And that doesn't just mean execute a query or things like that. But it also means, do you have a roadmap? Do you have the completeness of vision? And do you have the tools and the support and the services necessary to do everything that is required outside of the database? Okay, so do you have high availability? Do you have monitoring? Do you have replication? Can you integrate data? Can you move data? All those things that really are necessary to thrive and succeed in an enterprise environment. And that's where Gartner has really said that Postgres and Enterprise DB have that ability to execute in the completeness of vision. I want you to focus your attention on one key thing, which is what is not in this magic quadrant. No other open source relational database is still in the Magic Quadrant. If you page back in time, there were a number of them, and they've all dropped out for, well, reasons that Gartner doesn't necessarily share, but obviously today Gartner sees only Postgres as being an open source relational database that has the oomph necessary to support the enterprise. I mentioned we're working with lots of customers around the world. Many of them are Fortune 500 customers, and many of them are Forbes Global 2000 customers. So we're truly an international company and with a very strong representation in large companies. And I work personally with quite a few of them, and they are not using Postgres for little toy applications. They're using it for very, very important things, and you can see the names on here like Kronos and MasterCard and ABN AMRO and KT and Samsung. So they're really putting Postgres and the tooling and the know-how around Postgres to the test. But we're not just active on the commercial side. We are very involved in the open source development of Postgres. And I mentioned since 2006, we've been regularly contributing to Postgres. And today we are proud to say that quite a few big names in Postgres, such as Bruce and Dave, Robert, Amit, Devram, are part of our team. And they're contributing to Postgres. Some of them are committers, some of them are active in the core team, some of them are active as developers, and some of them are active in peripheral communities such as PGAdmin. For example, Ashish Vashi and Akshay Joshi are important contributors to PGAdmin. So EDB tries to walk a fine line and be successful for our customers, meeting large-scale enterprise requirements, but we do most of that by contributing heavily to the Postgres community. Okay. So now, before I turn it over to Raghav, Courtney's going to run a quick poll for us and share the results with the team. So, Courtney, if you don't mind.
Of course. So I just posted the poll if people want to start participating. How large was the largest database that your company migrated from Oracle to Postgres? So we'll give everyone a minute to log their vote. Still have some people actively voting, so we'll give it a few more seconds. Okay, looks like just about everyone has had a chance. So I'm going to close it out, and then we'll share.
What does it look like?
There we go.
Okay. So sounds like we're getting lots of migrations in sort of what today we would call the smaller end of databases. I'd say 5 or 6 years ago. The majority of what we're seeing also as a company would be in this segment of less than 1 terabyte. But we're also seeing people migrating very, very significant databases from Oracle to Postgres. Raghav, any comments from your side?
No, Mark, this is like a new step. Like everybody wants to do the migration, move from Oracle to Postgres. So the numbers looks like all are interested to move.
Okay. All right, good. So let me turn it over to Raghav now, and we'll start looking at different data migration techniques.
Can you see my screen?
Yes.
Okay. So before starting the data migration, I would like to do a small recap that we did in our last webinar. In last webinar, we discussed different phases, like if you are planning to move Oracle database to Postgres, then what are the steps involved? So we categorize that in 3 to 5 stages. So in these stages, what you will do is first you assess it. That means you need to know what are the three-tier architecture that is compatible to Postgres, like your application server, your database access to the database is compatible to Postgres or not. That is what first you have to assess, and you need to make a target. That means you need to pick a list of schemas, small or big, according to the complexity. You need to pick those schemas, and once you pick those schemas, next is schema conversion, because most of the Oracle version code objects or the storage objects are not directly compatible to Postgres. So what you have to do is you need to do a small conversion and apply some workarounds or any other methods you need to implement it. And once the conversion is over, the next phase is you need to do a functional testing. That means you allow your application to do the functional work. Once you see that all the objects you have converted are working exactly how you are expecting to work on Postgres or same like Oracle, and then you need to put some sample data and do a performance testing. Performance testing itself isn't a big area, but that is one of the key thing, because you may not get a similar functionality. Sometimes you need to do different kind of tuning and different methodologies that are there in Postgres. You need to pick up those approaches and do the testing. So that is one of the phase from your application. And after that is the data migration. So this is a real work, like from the production, you have to move your data to Postgres. And once the data is moved, you will do a cutover where your application starts working on Postgres. So in our last webinar, we have covered the first 4 phases, like, what are the tools available, how do you convert, what are the hurdles you might face when doing a schema conversion. All this has been discussed in our last webinar. Now, in this webinar, what we're going to see is the data migration piece. There are many strategies how we do the data migration on the basis of the size and how much would be the downtime and what are the tools available. All this we're going to discuss in another 40 minutes. And so the data migration is a process of selecting. That means you'll select data from Oracle, prepare, that means a dynamical SQL, or you extract the way you extract the data from Oracle, prepare, and then you transform the data from Oracle to Postgres. Once you transfer, then you apply it. So a simple definition is it's a process of selecting, preparing, extracting, transforming data, and applying the data to another database. In our case, it is Postgres. It's a general definition. So general definition of data migration. Now, in data migration, there are different methods. We categorize this in 3 methods. Like there, whatever you call in a different methods. Like, if you are extracting by simple SQL statements, or extracting a SQL into a small file and then applying onto the target, or whatever maybe, there will be 3 methods. First method is called a snapshot, and second method is like a snapshot, parallel in chunks, and third is CDC, change data capture. We'll go one by one. First is a snapshot. In this approach, what you'll do is you extract the data at once. That means you connect to the source database, extract the data, and write it to the target. So it's a one-time operation, and this is a very easy operation. Most of the tools will support this one. And next is a snapshot approach, snapshot in parallel approach. In this, you don't want to do it in one shot. So you want to do it in phases, or you want to do it in a parallel. So you will extract the set of tables in parallel, but in the same time. That means a schema level approach it is. if you have seen 2 to 3 schemas that are compatible to Postgres, you pick those schemas, you categorize those schemas and tables, and you run. You'll pass those tables to the tool, so it will parallelly load into Postgres. Now, the other approach in the snapshot is a large tables. Sometimes your schema might have a large tables, and if you start loading in a snapshot version, it could take some time to load into Postgres. So how you can do the large tables is cut into small pieces using a primary key, and using that primary key, you can load in chunks. So you can pass every set of primary key chunk to one process where it will use that tool or the script or the software to load from Oracle to Postgres. This is a parallel approach. So why we use this approach is to reduce the downtime. Okay, we'll discuss on the downtime part after this slides. The other one is change data capture. So this is a very important approach in this data migration. So what change data capture is, the transactions happening on Oracle are extracted into SQLs and then replayed onto Postgres. That is a continuous activity. That means you're not doing a one snapshot, you're not doing a parallel. It's like just extract all the DMLs that are happening on the Oracle and directly replay it onto the Postgres. So in this approach, there are 2 types again. One is log stream. That means this is more closely to the database that is on the source side. For example, every database will have a transaction logs. So from the transaction logs, you can extract the SQLs. And once you extract the SQLs, you can send the SQL statements to the target. That means that is Postgres, and you can apply it there. So it's one of the best model I would call, because it will reduce the downtime. And another approach, it's a traditional approach like trigger-based replication. So you set up some triggers on Oracle database, and those triggers will capture the DML statements happening on the Oracle, and it will use some catalog system to store them, and then those SQL statements are passed to the target via some processes, and those SQL statements are applied onto the target. So this is another approach. So these are all to reduce the downtime. So let me refresh these methods once again. You have a snapshot approach. That means one time you load the whole data to the target. And in the snapshot, there is another approach called parallel. That means you cut the snapshot by table or by table using a primary key. And next approach is a replication or change data capture, I would call, using extracting transaction logs or using triggers to extract the DMLs on the Oracle and then load onto the Postgres database. Now, overview. You can see the overview, what we were discussing in our last slide. If you see a snapshot approach, the first one, and the second one is the snapshot in parallel. That means you pass one table to one thread, or a large table with the primary key range, you will pass to one thread. That is the approach you can use for snapshot in parallel. And next is CDC approach. That means you can extract the data from Oracle by transaction log stream or using a triggers. So these are the 3 methods at a very high level you have today to load the data from Oracle to Postgres. Now let's discuss about the pros and cons of each methodology we discussed. Coming to snapshot, in this method, right, the data is loaded at one time. Now, when you load the data at one time, there is no restrictions on the data types. In Oracle, there are different data types. there are large objects, there are different data types related to XML. There are different types of data types. Those data types sometimes is restricted to load onto Postgres because of the compatibility issue or because of the data type may be different on the target side. So in snapshot approach, there is no such blockage. That means you can extract the same data types same data type and load into target uh, on the same compatible data types. For example, if you have a blob or a clob, that can go into text or byte in Postgres. And when loading this data, your application after loading the data, you can allow your application to access it. That means once the snapshot is over, your application directly start connecting to the target and function as like you are using to as with Oracle. And next is no special configuration is required. That means most of the tool will support this methodology. That means they will ask for a source connections and the target connection, and using that connection string, they spin up some of the processes and they will load data from source to target. Now, it's easy to manage. That means very simple configuration. Most of the tools will give a very simple configuration where you can just extract the data and do a snapshot. Now, what are the cons in this area is the application is down. That means during this operation, you cannot allow your users to do a write operations on Oracle database. So because you cannot get those deltas to write onto the target. So during this operation, your application is down. So then you can load the data directly to Postgres. Next is in some cases you can set your database to read only. That means where users can do selects, but writes are not allowed. And in this snapshot approach, if the snapshot is halted or due to some network or somebody has terminated the process or something goes wrong while the snapshot is happening, you need to reinitiate it because it's for the data consistency sake. That means in the snapshot you don't know where you have left. That's why you need to truncate the target and then reload it. So this is about the snapshot pros and cons. Let's go to the next method. In this method, it's a parallel method. It's the same snapshot, but parallel in chunks. Here also, the data is moved at once. And when moving the data, you can do it in two levels. One is schema level, one is table level. In schema level, you can list out top 10 tables. That means large tables should be used by one process and another set of tables. Like that, you can categorize and do a schema level load to Postgres. And next is table level. That means large table, you slice that table into small chunks using primary key, and then you load it. And most of the tools will give this option. I've seen tools that are schema level. That means you can pass a schema and you can pass the parallel option to it. So it will do parallelism and then load the data to Postgres. Most of the time, what I've seen is they do at a schema level, not at a table level. What I mean by a table level means if you pass one large table, it's not parallelly sliced and sent to the target. So there you need some manual work. In this approach, also the application is down, and you can allow read-only users, and a table with primary key is mandatory if you are going for a table level data load, and scripting is required. That means some tools has an option directly like -p or else some options where they will ask number of threads that way, but sometimes you don't have that option, but you want to use those tools. In that case, what you have to do is you need to write a script, and you need to call that script in NoHop or in parallel mode. So the scripting is mandatory here. That means if you have a proper scripting, it could be a simple bash or Python or any script. Using those scripts, you can load those tables to Postgres. The rule applies the same since it's a snapshot. If the snapshot is interrupted, you need to truncate and reload it because for the data consistency purpose. And next is CDC. In this approach, it's a transaction log approach. That means it's a replication, I would say. Here, the process are like it will extract the data from your transaction logs, and the other method is it extracts your DMLs via triggers, and the data is loaded continuously. That means what are the operations, what are the committed transactions happening on Oracle that are sent directly to Postgres, and those are all replayed. Okay, users can access the source database. That means there is no downtime here. That means no restriction to the write operation users. That means application can still function on the source side, and the data will be replicated to the target and written onto the target side. And for this approach, right, you need to have a replication software. So it could be a transaction log stream software. It could be a trigger-based software. You need to pick the software to use this approach. And one set of tables can be replicated here. That means it can be used for the partial replication. You might decide like in a schema, you don't want to send all the 10 tables to Postgres. You want to send only 4 or 5 tables to Postgres. Using this approach, you can do a partial replication. You can send a set of tables to Postgres. And as per my knowledge, most of the tools today are commercial in this approach. CDC, this change data capture is done by specific database vendors, and it's not open source. I'm not saying open source. Most are a commercial version. And the con.
Most of the well-known commercial vendors in this space, just for everybody to know, is people like HVR. I mean, obviously Oracle with Golden Gate, Trinity, or Quest SharePlex. And also from EDB, we have the replication server that does the same thing, uses a trigger-based approach to replicate, to do change data capture and change data replication from Oracle to Postgres. But as Raghav said, there really are no, at least to our knowledge, open source tools available in this space.
Yeah. Right. So the con side of this approach is like a small switchover. I still say it's a con side because though it is a downtime still it's a con. Like it's a small window you need to switch your application from source to Postgres, and all the tables should have a primary key. Without a primary key, you cannot get a row uniqueness. So that's why you need to have a primary key on the tables to replicate from source to target. When you're using this CDC approach, large objects are not supported. That means in Oracle, the large objects can go up to 4 GB. So that means, for example, XML or most of the data types in Oracle will go up to 4 GB. And using CDC approach over the network, it's not supported. What I've seen is most of the software is not supported to do a large objects, and it's a trigger-based in a trigger-based approach. Triggers are created on the source side. That means on Oracle side, you'll be creating some remote triggers. Those triggers will be extracting the SQLs. There will be a slight performance overhead on the Oracle side because it has to do a lot of extraction and write into a catalogs and then pass the data to Postgres. Here, one good thing is, though the network or due to some reason your replication is stopped, it can be resumed once the network is back. That means it's not like a snapshot version where you have to truncate and reload it, because here every SQL statements are captured into a catalog. That means it knows the event IDs. Because every transaction is like an event IDs, so it knows where it has left, and once the network resumes or somebody has restarts the process, it can start continuing from there. So there is a tracking system. So in this approach, you can easily replay from where you have paused. So these are some of the pros and cons about of all the three methods. So I would like to give a high-level summary here, like how you need to target all these three approaches. In snapshot approach, right? Downtime is purely based on your database size. For example, you have more than a terabyte of data. It could take a lot of time to do in one snapshot. That means it could be in minutes or it could be 2 hours also. So you need to do a first testing. That means in our phases we have assessed, we have converted, we have did a functional testing, we have did some performance testing. Now what you have to do is to fit your data migration approach in this category. What first you have to do is you need to load some sample data. You should have an Oracle production copy. Like developers sometimes use the Oracle production copy for their testing. So you need to do one data migration on your environment. Okay. So take a production copy, do a data loading using these approaches, and record the time, and also see what are the troubles you are facing while doing a data loading. In these three approaches, right, you may be using a tool that will do a one snapshot. You may be using a tool that will be doing a parallel snapshot, and you also using a tool to do a replication. So you need to know beforehand, before doing a production, what are the problems you are facing. So that is only possible when you get a production copy. So using a production copy on the source, use that dev environment and load onto the target. Use the target resources full. That means on the target side right now there is no application to access the data because there is no data. You want to replicate it. So use all the resources on the target, do a first load, and capture all the issues what you are facing, and record the time. So that is your downtime. On that basis, you need to see which approach you want to follow. For example, your application decides to go with the snapshot approach. That means why I'm saying application, because sometimes your application will have flexibility to go offline. That means you'll have a downtime window, like you give 1 hour or 2 hours, like you have a downtime windows like that. On that basis, try to load the data. It could be a snapshot approach, it could be a parallel approach, or it could be a CDC approach. In parallel approach, the main key is scripting. So if you do a proper scripting, if you use available tools properly, then you can reduce your downtime window. In CDC approach, there is no question of downtime, but still there is a downtime. So there could be a mix of cases. For example, you may have 10 tables. Out of the 10 tables, 1 or 2 tables are having a large objects, where CDC won't support that functionality. In that case, you need to rely on the snapshot approach. So it's a mix of a snapshot and CDC. So that's why I was telling there is a partial to small downtime there. So you need to, though you are using CDC, there is a downtime there. So in that case, your configuration is the key. So how you configure for snapshot tables, how you can configure for the replication tables. And when you are going with the CDC approach, there are some limitations. That means like primary key tables are not supported and large objects are not supported. So you need to take all these into consideration, and you need to make sure your data migration should fit in this one of these approaches. Okay. Now, coming to tools, till now we have discussed about what are the methods available. Now let's discuss on the tools. What are the tools available that will support all these three approaches we have discussed? Now, this is as per my knowledge, what I've collected. There could be other tools, but this is coming purely from my knowledge, like how where these tools will fit. So for snapshot approach, right, Aura2PG is an open source where you can use that tool that uses for a net wrapper, and it will load the data at once. Like it has a parallel options, and other tools like full convert, SPR. These are some of the tools that will also support a snapshot approach. Now next is snapshot paralleling check. In this category for tables, right? Tables means schemas. In schemas, you have a set of tables that you want to parallel it. You can use Aura2PG. There is a parallel option in it that will also pick the tables and load to Postgres. And Aura Migrator is another open source tool. And Enterprise DB's migration toolkit. This does exactly the snapshot and parallel. It will do at a table level. It will load from Oracle to Postgres, and it will change. You can pick the targets also. And table in chunks. That means if you want to slice a table on the basis of the primary key, then you need a module where it can do a select, where it has to allow you to do a simple select on the basis of a primary key. So if you have a primary key 1 to 10, for example, just giving an example here, 1 to 100, and you want to send 1 to 10 to one process and 20 to 30 to one process, like that, if you want to break, you need to pass a SQL statement, or you need to have some functionality in a tool where it can split the data on the basis of the primary key. Now, what I've seen is Oracle Foreign Data Wrapper as an open source. You can use EDB, DB-Link Aura, an extension. It uses a copy API, Oracle's copy API libraries, and it will extract the data on the basis of the primary key. That means you can pass a query on like where clause from ID number 1 to ID number 10. If you pass that query, it will get only those 10 records. Using foreign data wrapper also, you can pass a SQL to a downstream database. You can extract the snapshot. So using these two modules, you can load the data in chunks to Postgres. Now another method like CDC method. In CDC method, there are many tools, commercial tools particularly, and free to use also. One is EDB replication server. This supports a trigger-based replication. It also supports different sources, but Oracle is the one we are discussing in this webinar. So from Oracle, you can create a triggers. It creates remote triggers, and it will extract the SQL statements and load it to Postgres. And other tools, I would say Oracle Golden Gate and DB Convert. Oracle Golden Gate has a native, it's a native software to Oracle where it knows the transaction logs, it will extract, and it will send to a non-Oracle system database. So these are the few tools that will fall in these three categories as far as my knowledge goes. And this is a high-level picture about all the tools and where they will fall. One is replication server. Using replication server, it can do snapshot Snapshot in parallel is also supported, and it's a change data capture. When I say change data capture, I'm addressing here as a trigger-based replication, and your target can be Postgres Advanced Server. It's a ADB Oracle compatibility database and Postgres to community Postgres. Next is EDB MTK, the migration toolkit, what we call. That will do a snapshot, and snapshot in parallel is also supported. It will not do a replication. You can use AWS SCT. It is also data migration. It also has a data migration tool. It will do a snapshot. It will also has a snapshot in parallel. And these targets are going to a PostgreSQL, the community one, Aura 2 PG, Aura foreign data wrapper extension, DB-Link Aura extension. All these three you can use for table level in chunks, and that means snapshot in parallel is possible with these tools, and you can replicate to Postgres or Postgres plus Advanced Server.
That's some of the commercial tools that are out there that we as CDP have not used, but they are out there. Let's be complete about those. So companies like HVR, Attunity, and Quest Shaleplex are also providing many of these capabilities. Among others, they're focusing on change data capture, and many of them use a log parsing approach to do the change data capture.
Yeah.
I think, Courtney, I think you have one more poll, and then we want to go through some questions.
Yes, I'm going to launch this poll. We won't be sharing these results afterwards, so please feel free to answer as you please.
We can probably start with the questions at the same time.
Yes, so we have lots of questions that came through, so we won't be able to go through all of them, but we'll go through as many as possible. Also a reminder, if you want to get the socks, be sure to add your shipping address as well. We had a few people ask about the webinar that Mark mentioned at the beginning that was done previously. So I just wanted to say up front, we can include that in the follow-up email with the recording. We'll share a link to that other webinar that Mark mentioned as well. Okay, so we have a bunch of emails coming in first, or questions coming in. Let's start with how do you identify the objects that cannot be migrated to Postgres from Oracle?
Okay, you need to run a query first of all to find whether that table has a large object or not. Using that query on the Oracle side, you can identify that table can be migrated or not. Why I'm saying large object is only for the snapshot.
Yeah, okay, they can be migrated in the snapshot, not in CDC, right?
Yeah. That's the point I was trying to express.
So I think one of the ways to do that is if you use the EDB migration portal, which is free for everybody, you can upload your schema there and get an assessment if there's anything that cannot be migrated. But in general, all data types in Oracle can be mapped onto data types in Postgres, except maybe for the Oracle spatial data type, right? Raghav, that should be true, that we can pretty much map everything, but some things will go straight as is, and some need a mapping, and then some, you actually want to be smart about and actually use a smart mapping, because, for example, Oracle has no Boolean, but Postgres has a Boolean, and if you happen to use the integer data type in Oracle, but all you need is 0 and 1, you can save a lot of space and performance by actually mapping that to a smarter data type in Postgres, such as the Boolean data type.
Yeah.
We had a few questions that were along the same lines about the best approach for large size databases and what, if you think the CDC approach is good or what the best approach is for larger size databases.
Depends a lot on the available downtime, right? That would be the first question that you need to ask. Right? I mean, if you have let's say a 1 terabyte database or a 2 terabyte database, and you have all weekend, let's say hypothetically from Friday 5 o'clock till Monday 8 o'clock, you should do, as Raghav said, some testing, evaluate the performance of your network or the backplane or however you're connecting both servers, the data dump and the ingest speed, and potentially you could do 1 or even 2 terabytes on a weekend as a snapshot. It's uncomplicated, as Raghav said. You don't need to write any scripts. It's pretty straightforward. If that doesn't work, the next step, I believe, would be to do the snapshot in chunks, right, where you cut up the data and say you're going to run 4 or 5 different processes. And Raghav, I think we've seen some very interesting performance enhancements there. Can you talk about that? Some examples that you've seen?
Yes, related to parallel parallel in chunks approach, I would like to share one experience. I've seen a table that is more than 6 to 7 gigs. I'm taking a small example. It has a large object and everything, and it took more than 20 minutes to load. If it started with one process, and using a primary key approach and a small scripting, I have enabled 5 to 6 process. Then it has cut down to 4 minutes, and I used copy API method. It's Oracle's API library using debugging Aura. Then it has come to 3 minutes. So for me, this is all part of a testing, I would say, as you mentioned, Mark. Like there are many methods, right? We need to pick which method will fit there. So first time when you do first recording, the time is important. On that basis, you can start testing the other approaches.
It really depends on your data, as Raghav said. If you have 1,000 tables and they're all pretty much the same size, well, then you will do what Raghav said called the schema chunking, right? So you just cut those tables up into 4 or 5 or 6 different groups, and you disable the foreign keys, and you shovel all that data across in parallel processes. It's probably going to be the fastest. But if you have 999 tables that are of same size, and one table that has like almost a terabyte of data in it because it's a history table, then, well, that table should probably then also be chunked by primary key. So unfortunately, there's not one simple answer, especially if you don't have a lot of downtime available to do the migration.
Okay, thank you both. There are a few questions about case studies or customer references about migrations. I just wanted to say that we'll follow up on those ones afterwards just to make sure we get you the most valuable one for the experience you're asking about. Let's see, another question, which I think maybe a few people might have, so we should go over. Someone asked, how is the migration tool and replication server licensed?
Those are part of a subscription. So basically, most customers license them for a year. That's part of our general database subscription. And if you're more interested there, Courtney will make sure that somebody from our sales and marketing department follows up with you. But that's licensed on a per core basis. That's how we do it, and it's an annual subscription.
Great, thank you. A lot of the other questions are a lot more specific, so I think we'll take those offline and make sure that we follow up with each and every one of them. They'll be in the follow-up email along with the recording and slides as well. So be sure to look out for that in your inboxes. And thank you all for joining us, and we hope you have a great rest of your day. Thank you.
Thank you.